Today, solving radical equations, meaning we're just going to solve equations that contain radicals in them. So to solve equations that contain radicals, the whole point is going to be to undo the radicals by taking both sides of the equation to a power. So there's a rule in math that we use. If both sides of an equation are raised to the same power, all solutions of the original equation are contained among the solutions of the new equation, right? So we're going to get a different equation when we raise both sides to a power. The solutions of that new equation that we get after we eliminate the radicals by raising both sides to a power will always contain all of the solutions to the original radical equation. But the thing is, there may be some other ones too, okay? There may be some extraneous solutions, and so we're always going to have to check the solutions that we get in our new equation back in the original equation that contained the radicals, because some of the new solutions may be false or extraneous solutions. Okay? A proposed solution to the new equation after we've eliminated the radicals is not a solution of the original equation if it's extraneous, right? That's what we call an extraneous solution. So what's the rule then? In bright red, you must check all solutions after raising both sides of an equation to a power to see if they are valid or extraneous, one or the other. So let's just practice this a little bit. Okay, so what would the steps be then? I mean, if you had to break this down to kind of like a process, I don't know why we get 3 in there twice. I think it's supposed to be a 4. 1, 2, 3, 4. If I remember, that's how you count. So step 1, isolate one radical on one side of the equation. So you're always going to isolate a radical, raise both sides to the necessary power to eliminate that radical. If the equation still has a radical, you got to do it again. Then you got to isolate the other radical, raise both sides of the equation again to eliminate that radical. And eventually you get rid of all the radicals, solve the equation, and then you have to check all the solutions in the original equation before you ever raised it to a power, okay? So what's that involve here? What would I have to do first? I mean, first is isolate a radical. Do I need to do anything? No, that's already done, right? I've already got a radical on one side of the equation that's isolated. So what's my first step then? I have to square both sides because that's a square root. Okay, so notice when I square both sides, now we're on high alert here, right? Because we squared both sides, we know that we're eventually going to have to go back into the original equation and plug our solutions in just to check and see if they all work, okay? So what's that give me if I square both sides? What do I get on the left? On the right? Okay, that's easy enough, right? Add 1, divide by 2, and everybody agree we get 13, okay? So then we got to go back and check that, but we have to go back to the original equation that involves the square root to check it. If we do that, if I plug in 13, I get 26 minus 1 is 25. Square root of 25 equals 5. Check. It worked. Okay. So that is a valid solution. 13 is the one solution that we get to that equation. Okay. Give me thumbs. That all make sense? Okay. What about one like this? What would I do first? Good. I got to isolate the radical by adding 1 to both sides. Okay. Now what? Square both sides. So we got to remember at this point, we've raised both sides to a power. So that means we could have extraneous solutions. We're going to have to check. So I get what on the left side? X minus 1. Right side I get. And so the solution is 2. If we check that, what happens? That gives me square root of 2 minus 1 is square root of 1. Yeah, that all works out. Okay, so it's good. We go back to the original equation and checked it, and it works. We're good. Okay, how about this one? Move the 2x over. Okay, now we isolated the radical. Now what? Square both sides. Okay, so we know we're going to have to check things. Okay, now what does that give? On the left side, we just get x plus 1. I want you guys to tell me what we get on the right side. What right here, what do we get? No, not quite. How come? What are my options for doing this before I pick on somebody else? Okay, pattern would be the best, right? We could foil it out, but that's we don't want to do that, right? You guys should use patterns. What would the pattern be that we're going to use in this case? Okay, that one, right? We're going to use the pattern binomial squared. So Archer, what's that give you on the right side then?
64 minus 16x minus or plus 4x.
Minus, you mean, right?
Yeah, 30.
Because 2ab, okay, plus,
4x, right?
there you go, 4x squared. There you go. Okay, everybody see that? We're just using, and again, all we did was we just used the pattern. We just used the pattern a minus b squared equals a squared minus 2ab plus b squared, right? Okay, good. No big deal. Okay, now what would we do? Yeah, we can't isolate x because we have x squareds and x's, right? Remember the rule, we can't point to a single variable here. So we got to do something different. What do I need to do to that equation? Eventually, yeah, but before I can do any of that stuff, it's not in the right form yet. I got to set it equal to 0. So where would I move everything, to the right or the left? I would not move it to the left. How come? Why the right? Okay, yeah, so we're going to probably end up using, if you look ahead a little bit here, and we're getting to a point where you kind of have to think a couple steps ahead when you get to this level of algebra. We're going to get this thing equal to 0, and then how do you anticipate solving that equation we're going to get? How would you describe the equation we're going to get? A what? It's okay. It's quadratic. Yeah, it's going to be. I don't really care if it's a trinomial or a binomial, but what I do care is it's going to be a polynomial equation. It's going to be quadratic because the biggest power of x is going to be x squared, right? So think about our options here. How do you anticipate probably solving this quadratic equation? Are we probably going to take time to factor this one? And we'll talk much more about this in May, right? We're going to really focus on being strategic about quadratics for about the first week in May. But we've already we've let the genie out of the bottle here. If we end up with a quadratic equation where a is not equal to 1, we used to factor that by grouping. But if you think about that, that's kind of hokey because factoring may not work. So why would you take the time to try to find magic numbers and factor by grouping? I know I made you do that stuff because I want you to be good at factoring. But practically speaking, that's not how we're going to do it. We want to do things as easily and efficiently as possible. So what would we probably defer to instead of factoring in this case? The quadratic formula, right? We'd probably just go to the quadratic formula on this one. So the quadratic formula means that we've got to get this thing set equal to 0. And one of the criteria that we had for the quadratic formula is we wanted a to be positive, right? So we always want to make the leading coefficient positive. So we've got our x squared term has a positive coefficient on the right side. So leave it that way. Push everything to the side where you're going to get that positive leading coefficient. Okay, give me thumbs. That all make sense? Okay. So we'd push everything right, and that would give us that. Agreed? And then I just flip the equation to put the 0 on the other side. Okay. Now at this point, we would just solve this thing with quadratic formula, right? We're not going to try to factor this. If we could factor out, okay, well, we would try one thing. What would be, like, if we could luck out and be able to factor out a 4, if we had a GCF of 4, that'd be great, right? Then that would mean we could factor what's left over would be a simple basic trinomial that might factor very, very easily, in which case we would try to factor it, but we can't. We're stuck with that 4 out front. So we're just going to plug into the quadratic formula. And what would we get here? Some big number, right? If we do all that stuff, we won't take the time to calculate it. We're just going to get, if I did all the the arithmetic inside the radical, I just get an 81. That's what it works out to be. Okay. 33 squared minus 4 squared times 63 is 81. So we end up getting two pretty normal solutions. If we take the plus sign, we get 42 over 8, which would reduce to what? 21 fourths. If we take the minus sign, we're going to get 24 over 8, which is just 3. So those are our two solutions. 21 fourths or 3, right? We good? Should we just move on to the next problem? We got to check it, right? Because remember, we raised both sides to a power, so we've got to check this. We'd have to go back and check this in our original formula. So if we do that in the original equation, if we do that, 3 works, right? If I plug 3 in, I get a true statement. I get 8 on the left side and 8 on the right side. But if I plug in 21 fourths, I'm not so lucky. 21 fourths under the radical, 21 fourths plus 1 is 21 fourths plus 4 fourths, 25 fourths. Square root that, I just get 5 over 2. 21 halves plus 5 halves is not 8. That's not 8. That gives me 26 halves, which is 13. 13 is not 8. So that was a false solution. So only one of those we get to keep. Okay? Make sense? Okay. All right. Oh, yikes. What about this one? I've got 2 radicals. What am I going to do? How many times do you anticipate having to raise both sides to a power here? Probably twice, right? Now, if we didn't have that 2 there, we'd be fine. Because then when we squared both sides, we'd eliminate both radicals in one step. But we're not so lucky because the right side has a 2 minus the square root. And so when I square the right side, it's more complicated, right? You can, if you really think about this, and you guys are building intuition. Every time we do this stuff, you're building more intuition. If you think about the pattern that we're going to use to square out the right side, that's just a minus b quantity squared, isn't it? Right? We see that where a is the first term and b is the second term. When I square that out, in the b squared part of that, it's going to be great. It's going to undo the radical, but I'm going to get that cross term in the middle where I get a 2 times an a times a b. I'm going to be stuck with a radical when I expand out the right side. And we'll see that happen. So yeah, you're right. We're going to have to do this process twice where we're going to have to isolate a radical, to raise both sides to a power. You know, we have to do that twice. Okay, what do we do? What's our very first step here? What do you think? First step. If we go back to our strategy, what did we always try to do first when we're solving a radical equation? Isolate a radical. Do I need to do anything to isolate a radical? No, I've got one isolated right there, don't I? Okay, so we're good. So what would I do then? Square both sides. I've got to undo that radical on the left by squaring both sides. So there's step 1. Okay, now I squared both sides. So we've entered the danger zone, right? We got to go back at the end, and we know we're going to have to check for extraneous solutions because I might have just introduced some by squaring both sides. What does the left side become? Y plus 5. Okay, that one's good. Now, what about the right side? Who's up for the challenge on the right side here? Oh, come on. I'm going to pick on somebody. Might as well volunteer. Square that out for me. Okay, Tony, what do you get on the right side? If I FOIL that out, what am I going to get? Or if I square out that pattern? Again, all I'm doing, right, is I'm just using the pattern A minus B quantity squared, right? What is that pattern again? Minus 2AB. Okay, so we just got to do that here, where here's my A, there's my B, is the square root. Go, Tony, you got this. What do you got? 4. Two times A times B, what's that going to be? There you go. Four times the square root, right? Okay, so there I've noticed I'm stuck with a square root in that middle term, and then finally plus b squared is going to be no problem. What's b squared? There you go. Okay. Okay, everybody good? Okay, but notice when we do this, we've got another radical. So what am I going to have to do? Isolate it. So let's go ahead and collect all the like terms. I've got a 4 minus a 4. Some stuff cancels, right? That cancels with that. I could actually subtract those y's away from both sides. Those go away. And so I've really just got to divide by -4, right? To get that radical by itself. Okay, so if we divide by -4, we just get -5/4 equals the square root of y minus 4. So we did it, right? We isolated our other radical. Now what do? Square both sides. So what's that give me on the left side? Left side? Okay, square both sides. Right, so I get 25/16 equals y minus 4. So if I add 4 to both sides, what's that going to give me? Let's do some mental math here. 4 is how many sixteenths? No. What is it total? 89. There you go. How could you? Archer got it. How do you guys? Somebody else walk me through it step by step. You guys got to get better at this a little bit. Well, okay, I moved the 4 over. That's fine, but I got to be able to combine these. How many sixteenths is 4? Which is okay. Good. Okay. So I'm going to get 64 sixteenths plus 25 sixteenths on that side, which is 89 sixteenths. There you go. Okay, good. If I check that by plugging it in, what am I going to get? So I'm going to get, we'll just zip through this. So 89 sixteenths plus 5. 5 is just 80 sixteenths, right? So I'm going to get 169 sixteenths. Square root of that equals 2 minus 89 sixteenths minus 4. I'm subtracting 64 sixteenths, so that's 25 sixteenths. Those work out nicely. I could square root both the top and the bottom in both cases. And look what I end up getting. 13 fourths equals 2 minus 5 fourths. That's false. Okay. So yeah, the solution is the empty set. No solution. Okay, did anybody see a step here? Where do you think you could have anticipated that things were going to probably not work out? Okay. Somewhere in there. Here's where. Yeah, exactly. There's where you could probably look at this and say, okay, that's probably not going to work, right? Because the output of a square root is always positive. Agreed? Okay. So there's no value of y. You could look at that and say, what value of y could I ever have that's going to make the square root of something equal -5/4? There is none. There's no real solution. Might be another kind of solution, but there's no real solution, right? Okay. Might be. There you go. Okay, give me 1 to 5 on that. Does that make sense? Okay. All right, last one. Okay, yeah, go do it on the board. That's a good idea. Let's just zip through this one. So it looks like people were either there or they were almost there. What do we have to do first, everybody? Isolate. Let's isolate the first square root. Okay, we'll square both sides. Right. If we square both sides, it's going to give us a little bit of a mess, but I think everybody got that. Okay. If we collect like terms and push everything to the left side, we just get that. And at this point, there's no real reason to divide by -4. Let's just square both sides, because if I square a radical with a coefficient in front, big deal. We're just going to end up with 16 times 3x plus 4 on the right side. Everybody see that? Okay, it's easy to square a radical with a coefficient in front. You just square the coefficient also. And if we do all that stuff, you got this quadratic equation if you did the algebra correctly. And from that point, it's pretty straightforward, right? I wouldn't even, I'll tell you what, honestly, like I wouldn't use quadratic formula on that. I would just try to factor that. Can you find magic numbers that multiply to 80 and add to negative 24? Yeah, that's not hard, right? Negative 20 and negative 4. It's easier to factor. And so you get 4 or 20 if we check them both. They both work. They both work. Okay. So both would be valid solutions. Okay, that was pretty fast. I'll leave this up for the notes. I'll publish this today. So if you need to look back at it, you can. The assignment is up there. You got your work cut out for you, but you got a work day Monday. Tuesday, we'll talk about complex numbers, and then that's it for the next test.